Okay, so just now we look at bus C when we perform the grading of bus 1, for relay 1 and relay 2. So now we consider the fault at bus B, and then we're going to determine the grading between relay 3 and relay 1 and 2. So just now the fault level that happened at bus B is 12.2 kA, which we have calculated. And now we want to, the first step is we want to determine the IS, right? The IS, the setting current. So when we look at bus B, we look up, then the feeder, okay, just like at bus C, when we look up, the feeder is 400 amp. And then therefore we consider 400 amp, 450, or 480. But now, when we look at bus B, we look up, the feeder is 1000 amp. So we are considering either 1000 amp or 1000 divided by 0.95, which we get 1060 amp. And that's all. We do not have to consider the grading between relay 3 and fuse, because in between relay 3 and fuse, we have relay 1 and relay 2. And this relay 3 is only responsible for grading with either relay 1 and relay 2. And just now we have to consider an additional situation where we have to take 3 multiply 160 amp, is because relay 1 and relay 2 also need to grade against fuses 1 and 2. But now relay 3 does not have to do that. Therefore, the considered IS are only 2, either 1000 or 1060. So again, the same concept goes. We are taking 1060 amp as our IS because it is the larger one. So when you have a fault at bus B, then we want to determine what is the reaction time of relay 1 and relay 2 based on the TMS and the IS that we have determined earlier. So just now the earlier TMS is 1.65 and the IS that we have determined is 480 amp. So now the fault at bus B is 12.2 kA, and we substitute inside the extra inverse curve that relay 1 and relay 2 uses. So the reaction time of relay 1 and relay 2 will be 0.2 second, okay, when you consider the fault at bus B. So to ensure grading between relay 3 and relay 1 and relay 2, you need to take this value 0.2 second plus 0.3, because the standard that we have accepted is that the grading between relay and between any protection system should be at least 0.3 second apart. So we take 0.3 plus 0.2 second equals to the TMS multiply 80 divided by the fault current at bus B divided by the setting that we have selected minus 1 to determine what is the TMS of relay 3. So from here, we determine that the TMS of relay 3 is 0.822 seconds. So from here, we can say that relay 3 has a TMS of 0.822 seconds and also the IS of 1060 amp. All right. So I believe you can start to see the pattern of determining the setting of the relay now. So again, now we move up to one more bus, bus A. Okay, bus A is over here. Right? So now bus A, just now we have calculated that the fault current is 22.7 kA. Now, relay number 4, when we look at bus 4, bus A, and we look up, and when you look up, you have this particular feeder. All right, you have this particular feeder. And this particular feeder has his IS that he needs to consider. So this particular IS got 1000. Is it 1000? Let me have a look, right? Let me have a look. A, right? When you look up, it's not mentioned. It's not mentioned. Give me some time. I will get back to you in the next video, right?